to check the dimension to check the dimensional correctness of a given equation. So today's our topic is to check the dimensional correctness of a given physical equation, right?
Yes, sir.
Okay, so in this topic we learn how to check the dimensionally okay equation is correct or not. So every physical equation should be dimensionally based. This is called the principle of homogeneity. This is called principle of this is
Homogeneity.
called yeah this is called principle of homogeneity. Means the dimension of LHS would be equal to dimension of RHS. Are you understanding?
Yes, sir.
So here the dimension of each term on both sides of an equation must be the same. On this basis, we can judge whether a given equation is correct or not. Okay,
Yes, sir.
but a dimensionally correct equation may or may not be physically correct, right? So we will take one example regarding it. Okay, okay. So what we
Okay, sir.
do, we need to show we have an example for that. Example that is we need to show the expression of the t time period t of a simple pendulum. Simple pendulum means there is a one okay bob, and that bob is attached with a fixed support, and that is moving there and there.
Yes, sir.
My white screen is visible, right?
Yes, sir.
So this bob is moving here and there from its mean position. So the time period okay of this simple pendulum, okay, the length of this string is L. Simple pendulum having 2 pi root under L by G. Okay, time period
Okay,
t
sir.
equal to 2 pi root under L by G.
G.
Okay,
Okay, sir.
so so we'll check it is dimensionally correct or not. To check it is dimensionally dimensionally correct
Correct or
or
not?
not, correct or not. Okay, how we can
Okay,
do
sir.
that? Okay, example this time period t equal to 2 pi root under lg, a bob having mass that is m, and this bob is attached with a fixed attached with a very light string, inextensible string, massless string, and that is attached with this fixed support at point O, and the bob is moving here and there. At its extreme position it will go and then there stop, and it will return back to its mean position. In the same way this bob is going to another extreme position, and this distance will be same as the previous one, and it will go up to the last distance and then it will move back to its original position. This whole effect is happening under the effect of gravity. This whole phenomena is happening under the effect of gravity, and that is called acceleration due to gravity. So with the whole whole time period t is 2 pi root under L by G. How we can get to know the this equation is dimensionally correct or not?
Not.
Okay, so I'm just
Okay,
giving
sir.
you the solution regarding it. So we have a no time period t equal to 2 pi root under L by Z. So time here LHS dimension or dimension of LHS is time period, and that is T, right? It is
Yes,
coming
sir.
T. Okay.
Yes, sir.
Another, the dimension of RHS, dimension of RHS is 2 pi root under L by G. You are saying that 2 pi is a number that is having no dimension, but we have
Yes,
a
sir.
length, so we can say that length having, we can write in this way, length and acceleration due to gravity. It is a kind of acceleration. It is a kind of acceleration. So
Acceleration.
we have acceleration dimension LT minus 2,
2.
right? Hmm.
Yes, sir.
So we see that this L and this L will cancel, and I am writing over here t power, when this will be go up, it will become 2, and a square and root will cancel, and it will become what? It will become t, right? So
Yes,
you
sir.
are seeing that here you are seeing that the dimension LHS dimension is also t here, right?
Yes. Yes,
Hmm?
sir. Yes, sir.
And the dimension of
It means
RHS
that
is equal to 2 pi root under
TS
L by G, that is T,
T
that is T. So both are dimension are same. Both the sides have
dimension.
same dimension. है
Yes,
ना?
sir.
Hence both the sides have same
Same
dimension.
dimension.
Both the sides have same
Same dimension.
dimension. Right? Both the sides
Yes,
have
sir.
same dimension. So we say that this is dimensionally correct. Hence this is
Dimensionally correct.
dimensionally. Are you writing also?
No, sir.
Correct. It is dimensionally correct.
Correct.
Okay.
Okay, sir.
So you can note it down from here. I will tell you the question. To check the first, write it down. I'll
Yes, sir.
give you the uh, to check the
Next
dimension
slide.
correctness of a given physical quantity. Today's topic it is
Sir, next slide.
hmm, next slide. Yeah.
Sir, you
Eh? Yes.
next slide.
Write it down. I'm telling you. Every physical equation, every physical equation.
This is the statement
This
regarding
is the
this topic.
topic. This is the topic.
And this the
This is
what
the
you are
topic
saying.
of
What are you saying is the
uh,
statement of this topic.
yes, yes.
Okay, sir.
Now you need to write the brief explanation regarding it.
Yes, sir.
Okay, write it down.
Every physical equation should be
Every physical equation should be dimensionally correct or balanced.
or balanced.
Uh, Full stop.
Okay, sir.
This is called the principle of homogeneity. This is called this is called the principle of homogeneity.
Yes, sir.
Okay, so
Okay.
here you can write next line, the dimension of each term on both sides, the
The dimension
dimension
of
of the dimension of each term on both sides
both sides
of an equation
of an equation
must be the same.
must be the same. Yes, sir.
Hmm. On this basis,
On this basis,
we can judge
we can judge
whether a given equation is correct or not.
correct or not. Yes, sir.
Full stop. But a dimensionally correct equation
Correct equation.
may or may not be physically correct.
Correct.
May. Okay, so this one we have a one example regarding it. Write the question so that the expression of the time period t question so that the
Yes, sir.
expression of the time so that write it down so that the expression of the time period t
So that the
expression
expression.
expression
Yes, sir.
of the time period t
Time period T. Yes, sir.
of a simple pendulum
Of a single pendulum.
of length L
L. Yes, sir.
is given by t equal to
T equal to 2 pi root under L by G.
L by G is dimensionally correct.
Is dimensionally correct. Yes, sir.
Hmm. Now you can start solution LHS dimension. You can just get the information from white screen.
Yes, sir. I'm writing.
Hmm.
Yes, sir. Completed.
Hmm. Completed. Okay.
Yes, sir.
Okay. So we are going to go through. We are going to have another example Okay, let's check the
Okay, sir.
equation for the dimensionally homogeneity. Dimensional homogeneity x equal to ut, x equal to ut plus
Okay, sir.
half at square. Another example,
Yes, sir.
x equal to ut plus half at square,
180, sir.
where x, yeah, where x is distance traveled by a particle in time t, where x is distance
Traveled by.
traveled by particle in t time, in t time. Okay.
Yes, sir. Okay, sir.
Hmm. And u is the starting speed, u is initial speed, initial speed, and a is acceleration.
Yes, sir.
A is and
Acceleration.
a is acceleration. Okay.
Okay, sir.
Then calculate LHS term, RHS term. Okay, I will tell you how to do. Okay.
Okay, sir. I'm doing.
Hmm. Do it.
And what is the dimension of speed?
Speed LT minus 1.
Yes. And acceleration?
LT minus 2.
Sir, 2 LT के power minus 1.
Hmm. Okay, I'm telling you. You just have a look here.
Okay, sir.
LHS dimension, LHS dimension is x. So x having dimension L.
L.
Okay.
Okay, sir.
So this is LHS dimension, that is very easy. Now we can go on the other side, RHS dimension. RHS or dimension, that is ut plus half at square. Okay. ut plus
Okay, sir.
half at
Half 80 square.
square. Yeah. So what we do, for u we have dimension lt minus 1, and we have dimension of t as t, right? Plus
Yes, sir.
half. Here we have dimension of lt minus 2, right? And here we have t square, right? Are you getting?
Yes, sir. Yes, sir. But
Hmm.
UT में
lt minus
LT
1.
तो सही है
Yes.
तो,
Hmm. So
लेकिन T का तो
we'll
T नहीं
what
होगा
we
ना.
do? T, yeah. So t power minus 1 and here t, they will cancel each other
यस
and it
सर
will
सर
become L.
वो तो हाफ 80 है ना, उसका 2 दिख रहा है. यस सर.
Hmm. Okay, and this is 1 by 2 and that is L. So L is here L and t power minus 2 here t power 2, that will cancel each other. It become L by 2, that is 3 by 2 our L. Okay, so we are not going to considering about numeric
तो
value.
न्यूमेरिकल.
Okay,
हाँ यस सर.
numeric value is negligible, neglected.
यस सर.
Numerical 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 value
इज
is
नेग्लेक्टेड.
neglected.
यस सर.
Okay, hence we have that is dimension on RHS is L. Okay, this is RHS dimension. RHS dimension.
डायमेंशन.
Okay, RHS dimension, that is
यस
L.
सर.
So we have LHS dimension and RHS dimension, both are same. LHS
यस सर.
dimension,
इक्वल टू RHS इज इक्वल टू L.
LHS dimension equal to RHS dimension. RHS
डायमेंशन.
dimension. RHS dimension.
यस सर.
Clear? So in this way we can
यस सर.
solve the question. You have noted down
यस सर.
this line.
यस सर. एवरी लाइन.
Of, in this way you need to do the calculation. Okay.
ओके सर.
I'm giving you another example. Okay.
ओके सर.
Example number 3 we are giving solving. Check or test dimensionally if the formula t equal to 2 pi root over m by f by x
M by
root under
F by
m by
X.
f by x
ओके सर.
may be correct, may be correct, may be correct where t is time period, t is
टाइम पीरियड.
you need to write it down also like that I am writing
यस
now.
सर, आई एम राइटिंग आल्सो.
Yeah, m is mass, m is mass. Okay,
ओके सर.
f is force, and
X
x
is
is distance.
distance.
Hmm. So now the overall question is test dimensionally if the
Dimension
formula t equal to
2 pi root
2
under
pi root,
m by f by x
yeah,
may
may
be
be
correct,
correct, where
where
t is the
t is
time,
time period,
time period.
m is mass, f is force, and x is distance.
Yeah, solve it by yourself. Get the LHS
Okay, sir.
dimension.
सर रिच डायमेंशन तो टी आ रहा है आर एस में रूट अंडर एम एल टी स्क्वायर आ रहा है
LHS dimension is t, right? No issues.
यस सर
Now we are having RHS dimension. So now I'm going to calculate it.
ओके
You
सर
just have a watch. You just have a watch over here. 2 pi, it is root under m by f upon x, right? So
यस सर
we are not going to write the dimension of 2 pi.
यस सर
We are
सर
just
सर
uh,
हो गया
oh yeah,
मैंने
right.
गलती कर दिया
So
था
this
एम की
is
जगह पे ना एल लिख दिया था हाँ सही हो गया
oh okay. So this is
यस सर आ
m
गया
l for very good, very good. So
मास
m
को मैंने
l to
लेंथ
the
लिख
power.
दिया था
So you need to conscious about it. Make sure
यस
that
सर
this x will go up and it become l over
यस
there.
सर
Okay,
एम एल
m and l can
कैंसिल
cancel. Hmm.
and t to the power minus 2 will become t to the power 2 and when the
And
square
become
root is
t.
cancelling it becomes t.
Hmm. T. Good.
Yes sir.
So you have done this one, right?
Yes sir.
Very good. This question is finished. We have got the dimension of LHS as well as dimension of RHS, and we confirm that these are dimensionally balanced. These are
Correct.
dimensionally balanced. Correct. So
Balance.
it is it is the homogeneity of dimension. Okay.
Yes sir.
So I'm giving you another example. Right.
Okay
Okay.
sir. Okay sir.
Test dimensionally. Test dimensionally If the
Yes, sir.
equation, if the equation
Yes, sir.
v square equal to u square plus 2ax may be correct, okay,
Hmm.
may be correct. Test dimensionally if the equation b square equal to u square 2as correct. So you are
May be
knowing
correct.
that this v is the final velocity and this u
Yes,
is
sir.
the initial velocity, a
Initial
is the
velocity.
acceleration, and x is the displacement. Do it.
Yes, sir. Yes, sir. It is correct. LHS is equal to RHS.
LHS equal to RHS.
RHS.
So very good. Now you have a look over here. Okay. Dimension of
Okay, sir.
LHS. Dimension of LHS. Okay. So
Yes,
dimension
sir.
of LHS, that is final velocity, that is LT minus 1 and whole square, it becomes L
L
square
square.
T power minus
T square.
1.
No,
Uh,
sir.
yeah.
It is T square only. Minus 1
LHS
square is
dimension
if we are
V square,
squaring
it
any
is
number,
only
then minus sign will be neglected.
multiply
Yeah, removed now.
minus L p power minus 1, L to the power 2, that is L to the power 2, here 2, L and T to the power minus 1, and over the, T p power minus 1, and over it there is a
Yes, sir.
power 2. So this power will
Yes, sir.
multiply together and becomes L square T
Oh,
to the power minus 2.
okay, sir.
Okay, got it?
Yes, sir.
So this is the dimension of LHS.
Yes, sir.
Dimension of LHS.
LHS.
Now we are going to learn about dimension of RHS.
Yes, sir.
Okay,
Okay, sir.
huh. Dimension of RHS. That is, it has two parts, U square plus 2ax, right?
Yes, sir.
2x. So we have U square, so we can write it down LT minus 1 square plus 2 LT minus 2 and L, right?
Yes,
LT
sir.
minus 1 to power 2 and the next term is L square, it becomes L square T to power minus 2, right? Plus 2, and we have L square T to power minus 2, it's become 3 L square T to power minus 2. As I have told, for the dimension we are not going to bother about numeric value,
Numeric
so
value.
we'll neglect
Yes, sir.
this, we'll neglect that one, and it becomes L square t to the power
P to power
minus 2.
minus 2.
So in this way we are seeing that the dimension of RHS and the dimension of LHS we got as already L square t to the power minus 2 in the
Yes, sir.
previous, okay, screen. Here
LHS.
L square t to the power minus 2 dimension of LHS, and that is equal to dimension of RHS L square t square. So we say the equation may be correct. So right, thus right, therefore the equation may be correct,
Correct.
may be
Correct.
correct. Okay, so this is finished, right?
Yes, sir.
Now you need to have another question I am giving you. Okay,
Okay, sir.
on the question I am giving you, so this is 5 number, this is 5, right? The question is here on your screen.
Yes, sir.
The distance covered by a particle, you need to write it down the question.
Yes,
The
sir. I'm
distance,
writing.
uh, on the last I will see the distance covered
Okay, sir.
by a particle,
By
the
a
distance
particle.
covered by a particle in time t, in time t
Yes, sir.
is given by x
Is
equal
given
to
by.
a plus bt ct square plus d.
Okay, sir.
Okay,
Yes, sir.
so next, you know, find the dimension, find the
Dimension.
find the dimension of a b c and d, a b c and d.
D.
uh, okay, is given by x equal to a plus bt plus ct plus d ct square plus
CT
d
square.
ct square,
Yes, sir.
yes, plus d. Find the dimension I use. Do it.
Okay, sir. सर नहीं बन रहा.
Hmm. Okay, I'm telling you. Here the equation contains 5 terms, right?
Yes, sir.
Okay, there is one term is on the LHS and 4 terms are on the RHS side.
RS side. Yes,
All
sir.
all of them should have the same dimensions, right?
Yes, sir.
So here we have dimension of LHS, dimension of LHS. So
LHS.
according to principle of homogeneity, dimension of LHS should be equal to dimension of RHS. Okay,
RHS.
so dimension,
Yes, sir.
dimension of LHS. So dimension of LHS, that is X. So X having dimension L, X having dimension L,
Yes,
right?
sir. Yes, sir.
X having dimension L, and
And
this shows that the RHS terms are divided into four parts, but each part of RHS should have same dimension, right? So dimension of RHS, dimension
of RHS.
of RHS should be same. So we say that this dimension of LHS should be equal to dimension of RHS, that is A. That is A. So A
A.
having the same dimension. A having the same dimension, right?
Same. Yes, sir.
So, X equal to A means what? The dimension of A should be equal to dimension of X. Okay.
Yes, sir.
So in this way we say that the dimension of A will be L. Will be L.
L.
Yeah. In the same way, we have dimension of BT, that is also L. That is also L. Because
L.
each term of RHS, there are four terms. Each term of RHS should have same dimension. That's why they will add together. Are you understanding?
Yes, sir.
All the terms should be same, all the dimension of the term should be same, then they are able to add together, right? They will add each other, right?
Yes, sir.
So all the having same dimension, so here bt equal to L, bt dimension of bt is equal to L.
L.
So we can say that, yeah, so we can say that b equal
B is
to
dimension LT to the power minus
dimension
1.
L by t पे power t will come down, t will come down,
Come down.
dimension of t
Okay,
will
sir.
come down, and it becomes what? L t पे power minus 1. So in this way say that b equal to dimension lt minus 1. Okay.
Okay, sir.
In the same way we have dimension of c, t square, ct square equal to L, it equal to L. So we say that dimension of C equal to dimension of L by dimension of T square. This is LT minus 2.
Yes,
LT
sir.
minus 2.
Minus
It
2.
is like
Okay,
a
sir.
acceleration. It is like a acceleration.
Acceleration.
Uh, then the last one is what? D TQ. DTQ, right?
Q.
I forget
Yes, sir.
their Q, no? Okay, don't worry. So
Okay.
DQ is Q. This is L. This is L. So
L.
dimension
Okay,
of
sir.
DTQ should be also L. Are you seeing
Okay,
that?
sir.
Dimension of LHS
Yes,
should be
sir.
equal to dimension of RHS, and
RHS.
each
Yes,
term
sir.
of the RHS having same dimension. So here
Dimension. Yes, sir.
DTQ is equal to dimension of LHS and dimension of RHS should be equal to
Its dimension should be L to the power minus L T to the power minus 3.
yeah. This is T power 3. So
Minus
that is
3.
L T power 3. What is this
Minus 3.
dimension? This show that which dimension?
Mm,
This shows that the dimension of density, this LT minus Q, length by time per power 3, okay?
okay,
This
sir.
would be what? You just guess it, okay? You just guess. So this is what the dimension of D, and this is the dimension of C, and this is dimension of B, and this is dimension of
B.
A, okay? A.
Okay, sir.
So all having A having dimension L,
Yes, sir.
tell me, B having dimension,
L to the power minus 1.
C having dimension,
L to the power minus 2.
very good.
And D having L to the power minus 3.
Yeah. So this is overall, right?
Yes, sir.
Anything? Doubt? Any doubt do you have?
No, sir.
Now you are very comfortable with this white screen?
Yes, sir.
Any doubt?
No, sir.
Okay, so tomorrow we'll okay have a next topic,
Hard
right?
application.
Prince, Prince, and we'll learn that one tomorrow. Okay.
Okay, sir.
So for
And next
now,
topic?
I'm giving you one more question, so that for tomorrow you will make this one, right?
Okay,
Huh?
sir.
The
Okay, sir.
velocity, the velocity v of a particle, the velocity v of a particle depends upon time,
Upon time, yes, sir.
depends upon time,
Yes, sir. T.
yeah, depends upon time t.
Yes, sir.
According to the equation,
Yes, sir. According to the equation.
according to the equation, v equal to
Yes, sir.
v equal to a plus bt plus c by d plus t.
Yes, sir.
Then write the dimensions of a, b, and c.
It is similar like previous question.
Yes, yes, but very important. Write the
Okay, sir.
dimensions of A, B, and
B, C, and
okay,
D.
A, B, C, and D. Okay,
Yes, sir.
so this much only for today class. Tomorrow you will
Okay,
come
sir.
and I will see that. You just show me the, you just show me your
Yes, sir. I'm showing.
paper. Yeah. This is first, right?
Yes, sir.
2 pi root under L by G. This is okay. Next, ut plus half ut square. Then this is all the terms A, B, and C,
Everything.
and okay. You got it? No.
Yes, sir.
Okay. And if any further question will be there, I will send through, you know, WhatsApp.
WhatsApp.
Okay. Uh,
Okay, sir.
so thank you so much for attending this class. Right. Next
Okay, sir. Thank
tomorrow
you so much.
I will tell you the schedule for that. Okay.
सर काश पहले ये आपके बारे में पता होता तो बोर्ड के एग्जाम में ज्यादा मार्क्स आता फिजिक्स में
वे कौन सा
बोर्ड के
व्हाट
एग्जाम्स में मतलब 1 साल हो गया ना आपको जैसे कि ये ऐप
हाँ
रहता तो आप कहीं से भी मुझे क्लास करवा देते
यस 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 तो
हाँ
ये सही है जिसको भी है मतलब आपको और भी कोई फ्रेंड होगा तो अगर आपको जरूरत लगेगा तो
यस सर
बोलिएगा
मैं
ठीक है
करूंगी अगर किसी को हाँ होगा तो
हाँ ओके तो
ओके
ठीक
सर
है चलिए थैंक यू बाय कोई इसमें कोई
थैंक यू सर
दिक्कत तो नहीं लग रहा है इसमें
नहीं
बिल्कुल
बिल्कुल नहीं
फैमिलियर
सर
लग रही हो हाँ
यस सर
और ये हाँ ये काफी कंफर्टेबल भी है मतलब कि आपको कहीं बाहर जाने उने की जरूरत नहीं है यू कैन लर्न फ्रॉम योर होम आल्सो राइट
यस सर यस सर
ठीक है चलिए तो थैंक यू
ओके थैंक यू सर
ओके